name is Syukri bin Muhammad Akmal, and today I would like to present my final year project proposal entitled as Prediction of the Mechanical Properties of Material using Guided Ultrasonic Wave FEM Simulation. Next slide is a presentation outline that consists of four main agenda. The first one is a project summary. The second one is introduction and background that consists of literature review, problem statement, objective, scope of material, and the limitation of the study. The third one will be the methodology, and the last agenda will be expected result. Move on to the first agenda, which is a project summary. This project is carried out to characterize the material properties of a composite material by utilizing 3D finite element analysis of guided ultrasonic wave. Signal responses and the properties of wave such as velocity, wavelength, arrival time, maximum amplitude and reflection is used to obtain the acoustical properties of the composite. By analyzing the ultrasonic wave properties, the material properties can be determined. All factors influencing the behavior of the propagated guided wave will be investigated to any variation in the signal behavior. By accessing the signal obtained with the different thicknesses, layout arrangement, excitation frequency, and monitoring directions, the material properties can be deduced. Next, proceed to the introduction and background. Introduction and background can be explained in detail at the literature review. The first point in literature review is a mechanical testing for material characterization. The mechanical properties are those which is influenced by the mechanical quality and capacity of the fabric or material to be molded in appropriate shape. These properties are related with the capability of the material to resist mechanical strength and sag. They also can be measured in terms of behavior of the composite material when subjected to the constraint. The mechanical properties also can change with the heat treatments handled as well as the working temperature. Lastly, strength, toughness, and hardness of the material can be measured after the material shaping handle. For the second point is NDE for material characterization. NDE is known as a non-destructive evaluation that become the engineering discipline which is encompasses quantitative measurement techniques, physical model for computational analysis, statistical consideration to detect flaw, and characterization by ensuring the validation of the system and performance reliability. The incorporation of NDE contemplation within the plan organize simplified life cycle management and move forward security of a structure once it's in benefits. NDE technique also make it feasible to control the fabricating, especially material handling techniques. NDE also can be very economical way to demand for process control. The third one will be the non-destructive testing. Non-destructive testing is a process of evaluating the material to find its characterization or to detect the defects according to a certain standard without changing original property or corrupt the object that under testing. One of the advantage is NDT can be done spontaneously while the machine or the system is still operating. NDT also can divide it into two, which are contact and non-contact. Next is guided ultrasonic wave. Guided ultrasonic wave is a NDT that are widely used in inspection of thin wall structure component. Then it was widely used due to its advantage that able to travel in a large distance using a low excitation frequency. Then it's also as a higher amplitude amplitude that will lead to a longer propagation distance. Other than that, GUV also can be formed in the two modes, which is symmetric (SN) and anismetric. Sorry. Okay, the last one will be the FEM. Finite element method (FEM) may be a numerical scientific strategy to use to imitate a physical wonder by employing a finite element analysis (FEA). By using FEM, numerous parametric considers can be done without causing many material waste. FEM is a positive for GUV within the composite to use. Usually, FEM has the capability to deliver animation and physical introduction for a better understanding of GUV behavior, as it will permit a visualization of a guided wave propagation and diffusing in the composite plate with or without defects. Okay, next we move on to the problem statement. For problem statements, anisotropic and inhomogeneous character of composites affected the analyzation of behavior in composite laminate. Then, simulation required to recreate the circumstance of GUW examination. The third one will be the high computational demand, necessitating the use of a high performance CPU. That's all for problem statement. Then we proceed to the objective. There is two main objectives of this project. The first one is to analyze the mechanical properties on guided wave propagation in several composite material. Then, it, then the second one is to assess the scattering behavior of propagated guided wave by deformation on the composite material. Scope of work. The first one will be the preparation of 3D FEM models with automatic parameter modification using a program of MATLAB. Then it will be then the simulation of the GUW propagation and scattering in the composite formation through Abacus Lab, and then MATLAB was used once again as a program codes to conduct the signal analysis. Okay, the next section will be the limitation of study. There are several limitations of study in this project. The first one will be the plate size of all cases is 500 mm times 500 mm, which is suitable for the simulation working and computational performance. Next will be the defects value is expressed in a millimeter, which in a millimeter. The third one will be unidirectional plate that are constructed from a composite material with a two distinct material qualities. The third one will be the composite plate layout configuration emphasized across ply. The fifth one will be the impact damage in the reference to based on the ultrasonic C-scan result of the composite plate subject to a 7.4 joule impact. The sixth one will be the displacement and matrix fractures is achieved, reducing the existing materials properties. And the last one will be the sensitivity in the defect detection, making the A not wave mode chosen as the frequency was set at 120 kilohertz. Proceed to the methodology. The first one is start. The second one will be the gather the data for the parameter. All the data or satisfied parameters selected into the MATLAB software, such as the size of the plate, the excitation point, the frequency, and the material properties of the plate used. Then proceed to insert data in the MATLAB and running the coding. After that, the outcome file will be transferred into the Abacus. In Abacus, there will be run simulation. There will be some simulation and save back to be transferred to MATLAB. If after the outcome collected and presented in a form of graph, there will be several validation before it was complete. If the outcome satisfy the needs, the experiments end, and if it's not, it will repeat to the number three step, which is which is to find the suitable parameter to be selected in the MATLAB software. The last agenda will be the expected result. As expected result, the propagation of guided wave is influenced by the material properties, such as lower attenuation in homogeneous material. The second one will be the higher velocity in homogeneous material. The second one is a propagation of guided wave is influenced by the material properties. Lower attenuation in homogeneous material, higher velocity in homogeneous material, The third one will be the directively of the GUV propagation will be depend on the fiber arrangement in composite material. As I have run one of the simulation with a simplest with a with a smaller size of a plate. As you can see that from the graph, the incident wave of the higher frequency is spread away evenly from the excitation point. Then this happen because the wave transfer from the insulation will give a less penetration as the amplitude of the wave decreasing. Reflected wave can be seen due to the deformation and the boundary of the plate. Reflected wave also can be minimized by adjusting the parameters such as excitation points, monitoring points, and time step. Polar plot of application is plotted as homogeneous as the simulation is run on a plate with no defects. Homogeneous materials such as carbon fiber plates have elastic behavior of a single homogeneous that holds true for a high frequency in a MHZ regimen. An accurate result can be obtained when the actual size of plate and other parameters is chosen in the FYP tool. Here are the references that I have used while completing my proposal. That's all from me. Is there any question? The panel can contact me through my emails or my phone number as shown in the slides. That's all from me. Thank you.